So, good afternoon, everyone. My name is Linh. I'm from VNU University of Science, Hanoi, Vietnam. And today it's my honor to be here to present about our research. It's named Building Deep Learning Model for Detecting Coffee Trees Changes in Vietnam using Sentinel-2 image. And my presentation has 5 parts. I will introduce about our background of coffee ecosystem in Vietnam. And I will talk about our research area and deep learning model, the result, and I give some discussion and then conclusion. Now I will move to the first one, introduction about our research. Each year, consumers drink over 400 billion cups of coffee, and it costs more than $100 billion per year. So, coffee is a significant key to the economy of the tropical countries, especially in Vietnam. You can see in the table, Vietnam is the second largest coffee exporter in the world, and we have the high potential to become the largest if our government and forest manager have a good policy, and it can supported by some high technology. To do this, we have mainly secretary to monitor the coffee development, and we spend a lot of time and money to go to field trip, take the sample of the soil, the plant, and the land cover, and then we processing them into the laboratory, and then generate the complete map of the crop planning. With the strong development of deep learning and machine learning recent year in many other domains, we decided to use deep learning in remote sensing to solve our problem for 3 main reasons. The first one, to enhance the life of coffee farm workers and their family, and to boost the productivity of the coffee production region, and the last one is to avert either the forest cleansing or depletion of other natural resources. So, in this study, we aim to combining the deep learning with the remote sensing data set, and we design UNES network to solve this problem, to classify the coffee plantation area on Sentinel-2 image and show how do coffee land cover changes in Vietnam over 3 years. Now I will describe in detail about our research area. This is the picture of the coffee bean growing belt, and all the top of the coffee producing countries as in this belt, and it's called bean belt. It's located between the tropical of Cancer and the tropical of Capricorn. And there are 3 types of coffee in the world. They are Arabica, Robusta, and the combination of Arabica and Robusta. Coffee also has some specific requirement to develop and generate the high quality of coffee. And for example, the rainfall, the temperature, the humidity, and soil. So you can see in this picture, our Vietnam is also in the bean belt. We also study about the coffee production system in the world, and there are 4 main types: rustic, traditional polyculture, commercial polyculture, and safe monoculture. And in Vietnam, our coffees are in the third and the last type. So here are some pictures of our research area in detail, and you can see in the right hand is a Vietnam map with some growing coffee region from the north to the south of Vietnam, and each green point in the map is the development of the coffees in the region. And with our map, we focus on the central highland province of Vietnam, especially Đắk Lắk province. Yeah. So we choose Đắk Lắk province because the coffee is planted in more than 70% of land in this region. And we took about 215 sample control points with 100 meters of radius that we survey. And our region is about 30 multiplied 40 kilometers. So with our research area, we design this workflow here, and we do 3-step: data collection, preparing input data, and developing the model. Firstly, we take the Sentinel-2 image of Douglas province from 2019, and we do some survey, field trip survey about more than 100 sample control points, and then we do some pre-processing about our data sets, such as image segmentation using a mask, and split our data set to sub-image. After that, we divide our data set to training data and validation data and testing data. So we put them in our model, some deep learning model and some machine learning model, and we also use some optimization technique to get the best parameter. And lastly, we use our model to our new testing data and evaluate the result. So this is our image architecture with the inputs are Sentinel-2 image with 4 bands, and the outputs are the coffee and cover types. And our model has 76 layers with some layer of convolutional layer, concatenate layer, mark pooling layers, and we also use some techniques such as batch normalization, activation, and dropout to get the best parameter. There are 3 options of our input side of image, and we also use 4 optimizer functions. They are all the best optimizer functions in deep learning nowadays, and we also do some experiment with this. So now we will see what we obtain. I list here the performance of our 40 model for classify coffee land covers. And you can see in the table we list 12 models of EMS architecture and 2 models of machine learning. They are SVM and random forest. And we list here the training size, the loss accuracy, and also the training time. And we can see that all the deep learning models are better than machine learning model. It can explain that maybe the convolutional architecture, especially EMS, are designed for solve some problem related to the image processing, so it can capture the image feature. So maybe it's slightly better than machine learning model. With our 40 model, we put the loss and the accuracy for each model over 15 efforts. And we list here our 5 best models with the loss and the accuracy are currency, and but the accuracy is a little bit changes and variable. So this is our 5 best model on 3 cases. Each case is each year of our data set, and we highlight our 2 best model. They are EMS Adam 256 and EMS Adadenta 128. So with our experiment, we also do some tests with the new input data. They are 54 Sentinel-2 images from Central Highlands of Vietnam from 2019 to 2021. And in fact, we have spent a lot of time and money to generate the complete map. We only use 30 minutes to predict the outputs of each year image, and with the nearly 95% of accuracy. So with the discussion, we have some comparison between our model to the government value. The government values is in the blue line, and our models is the split line. And in this picture, you can see that our best models is EUNET Adadenta 128. So I list about the analyzed time to the Sentinel-2 image from 2019 to 2021, and with our 5 best model, we can see if the inputs of the models is the larger, the time maybe is lower. So in conclusion, in this research we studied about developing deep learning model, especially EMS architecture to classify the coffee land cover changes in 3 years of Vietnam, and we see that our EMS Adadenta 128 model with nearly 95% accuracy is the best model. It helps us to save time and expensive to collect sample and generate the crop planting, and maybe it's been become a promising tool for another plant in the forest. Besides our research, we also use deep learning for different fields related to the forest science in Vietnam. For example, to monitoring production forest over time, to detect the tree and count the tree in the forest, and also to build the forest ecosystem service assessment. These are some references of our presentation today, and thank you for listening.